All right, so question 2 is always going to be from beams. You need to know beam to beam connections. So I'll start with this question paper, then I'll go to this one, and then I'll go to this one. You will see that the questions are very similar. What they change is just the type of structure, the shape or how many beams are connecting to how many columns. So like this question, they're saying figure 1, diagram sheet 1 attached shows a steel structure. Make fully detailed drawings to scale 1 to 10 of the beams marked B1 and B2 only, and give enough information for the manufacturing of the beams in a structural steel workshop. Plates are to be 10 millimeters thick and M20 bolts are to be used. So at least we understand the end plates that will be welded to the beams so that they can be connected to the column, 10 millimeter thick. They don't usually give you the size of the end plates, but they'll give you the thickness of the end plate. Show the following. You need to show the column centers. I'll show you what the column centers are. The length and the sizes of the beams, dimensions of the beams over the end plates, dimensions for the drilling of the bolt holes, and then the view with the dimensions of the end plates, which is the side view to show the end plate with how the holes are positioned.
Yes.
And then item marks, meaning that if it's beam 1, how many of them do we need, the number of beams required and the diameter of the bolt holes showed, and then the top of the beams. Okay, you'll see where the top of the beam is shown. Use your own discretion for information not given. So how many marks is this? 25. Just for the 2 beams. So let's go to diagram sheet 1 because they said it's diagram sheet 1. And then we focus on beam 1 and then beam 2. Then after I finish reading through and analyzing there, we'll go to the second question so that you see. Then I'll show you how you approach. Beam 1 and beam 2 is what they're asking for. And then we go to diagram sheet 1, which is this one. Okay. It's a steel frame. It's a frame structure. It's got the truss there. You've got columns. And then beam 1 is this one. Universal beam 1. Beam 2, we have 2 of them. So when you are doing the detailing of beam 2, you are going to say 2 of, because there are 2 beams, beam 2, of the same size. So that the guys that will be manufacturing or cutting the beams, they know that, the beam of this shape and this size, they're supposed to be 2 to be used here. And then when we come to beam 1, there's only one beam 1. But what we look at when we come to beam detailing is that what will be the connections, especially at that point. And here, you have to show the detail of the positioning of the holes here because it's joining to the column. So here we only need to show the bolt hole position, but when we come to the sides of the beam here, we are going to show the end plates and the position of the bolt holes on the end plates, okay, which is the same applies to here. When you're doing detailing of the beam, you need to show the end plate detailing, dimensions of the end plate and the bolt hole positions and their dimensions. But when the beam is connecting to a column like this is a column to beam. Because the beam is big, then the column is here. We don't show the cap plate because there's a cap here. The cap will come with a column. So the detail of the cap plate will be done when we do a C1, if ever they want detailing of C1. But what do you show on the beam at that position? It's only the bolt holes position and also the flange thickness. When the beam is sitting like this, you have to know that this white piece here, this is a web. The top piece, which is dark, is the flange, and the bottom part is the flange. When you go to the side of beam 1, you must show us the I-beam. You will see the shape of the I, which is the I-beam, which is also the same here. So we understand on the beam. And what they said is when we are doing the detailing, we must show the column centers. This is the center of this column to the center of that column. Why? Because even this one, yes, this center also, the dimensions are given here. These are column centers. So we usually start with these center lines and then offset by 600 you get to the next center line, then 1800 to the other center line. But again, before you even start the detailing of the beam here at the end, you need to understand the size of the beam, the column that is joining to, like C1. Why do we need C1? We need C1 because when I zoom like at that point, the column has a flange here. This is the flange of the column. This is the web. The white piece is the web. This is another flange. So this beam is connecting onto the flange of the column. You get some other questions where the beam is connecting into the web inside here. Maybe it's turned the other way. But the way we look at these ones, where you see the dark portions, these are the flanges of the H-sectional columns. So this beam has its I section, connecting on the face of the flange of this column using the end plate. And that end plate comes with already welded on beam 1. It's not going to be welded on the column, but there must be both hole positions on the column at a distance. You can see this is 1000, it's on top of the beam. So you need to come half here by the half of the beam height, whatever the beam height, beam 1 is or beam 2, so that you know that it's in the center. It's going to be connected somewhere in the center there, if we follow. So which is also happening here. If I see C1 and C2 are the same, we can go to the information here. They are saying C1, C2, C3, C4. They are all universal. It's not universal beam. This is universal columns, okay, not UB. It's supposed to be universal columns, and the sizes are all the same. Can you see here?
Yes.
Yes. So meaning that if the columns are all the same size, it will be easy. Once you do a detail here, you can mirror here as long as C1 and C2 are the same. Then whatever the hole position will be here will be the same on this side, because they are both of them connecting to the same beam. I don't know if you understand there. I'll show you the example of what we do. Yeah.
I understand perfectly. I can also see the top view, basically.
Good. I know with you, you know most of the things you're dealing with. So if you can also see the top view, that's better.
Yeah, then you know how to draw it, basically. Because you know what the columns are there for, and the positioning of the columns. You can just basically by hand draw yourself a top view.
Correct. So like I was saying here, where C2 is connecting to beam 1, you can show us the bottom, I don't know if you can see from the bottom. You say at the bottom it looks like that.
Yes.
Just a little bit with a flange. Just cut a flange a little bit and show the hole positions. 4 of them, you'll see how we space them. Then when we come to beam 2, it's also the same. Beam 2, beam 2. Beam 2 is connecting to C4 and C3. So the hole positions here will be based on the size of beam 2. When you're doing beam detailing, the hole position on the column will depend on the size of the beam. Then when we come to column detail, the position of the holes on the column will depend on the size of what? The column and the beam that is also joining to. But that is how we're going to do here. Then the hole positions here and that side is a mirror image, being that column C4 and C3 are the same. So it's just a mirror image. The only important part to know is top of beam, like they are giving you this 600. But you measure from the top here, from the bottom here, all the way to there. What is the height to the top of beam? Then you measure also the center to center, meaning the column centers. Then without forgetting the half of a column, what is the distance from here to the outside of the flange of the column? Then from the outside of the flange of the column, you are going to put down the end plate. But usually before you even put the end plate, they say that you need to leave a clearance of 3 to 5 millimeters. Then it's the end plate. Then end plate, they have said that is 10 thick. After the end plate, then you can show the beam, and the length of the beam will be indicated. Okay, let's have a look at this other question paper and see how it came. You see the structures, they are different. This is this shape. Look at this other one. It came like that. So if you go back to question 2 in this paper, they are asking us for the beam detail, also 25 marks. But what are they saying? Scale 1 to 1, beam 1 and beam 2. Also, supply enough information. Just the same question as that. You go and look at beam 1 and beam 2. When you go to beam 1 and beam 2, let's go there. This is the structure. There is our beam 1. So in this case, beam 1 is joining to C1 and C2. Then beam 1 again is joining to C4 from the top. Center lines, which is from here to here, column centers, 1, 5, 1, 5. Okay, then that is beam 1. When we go to beam 2, this is beam 2 here. What are the sizes? They give you information here. Like beam 1 is universal beam, 254 by 146. We know what is 254, right? We checked last time. It's the height of the beam. 146 is the breadth of the flange of the beam. It's 146. And this is an important length, or the breadth is very important because it's the one that is going to determine the hole positions. When we go to the blue book, we look at the breadth, not the height. So the breadth is 146. To find the hole positions, the pitch, the edge distances and all that, we look at the breadth of the beam or the edge section column. So B2 and B3 are the same but different size. It's 203 by 133 breadth by 25 kgs per meter. Then C1, C2, C3, they are all universal columns of the same size. C4, different size. You can see it's a universal column, but it's a bit thinner. The breadth is thin than 203. Okay, and then they tell you that use the end plates to be 10 millimeters thick, and every connection needs to have 4 boards, but equally spaced. How to space them, we are going to the tables, and they are all M20 boards. The base plates, I will come to this when we come to do detailing of a column, because when you do detailing of a column is when you talk about the bottom here on the ground. That's where you get the base plate, and the thickness of that base plate is always 20 millimeters. They also want only 2 boards. How to position, we are going to explain on that part. So they only want beam 1 and then beam 2, just like I was explaining on the other question paper. At this point here where C4 comes into B1, I think you know that the edge of this column is sitting on the flange of B1. Yes?
Yes.
And the I section of B1 is sitting on the flange of column C1, which is also happening there. So when we come here, we don't need you to show the cap plate, because the cap plate is welded on the column. It comes with a column already welded with it. Here we only need to know the hole positions that are aligning with the hole position on the cap plate of the column. But the beam will come with the end plate with the holes already drilled. Those holes must align with the holes on the flange of the column. Same applies to there. So because it's a beam detail, then you must show the end plates detailing, not the cap plates. Cap plates we usually detail when we're doing the column detail. Clear?
Yes.
Okay. The last question paper I opened is this one, which here is this. Let's go to question 2. Also 30 marks. Look. 30 marks. B1 and B3. So in this question, they want detailing of B1 and B3 and give enough information. Okay, all that information same as the other papers, but B1 and B3, you go to the sketch. This is the beam. Beam 3 and beam 1. You see they didn't show beam 1, so I'm not sure which one can say beam 1. I think this paper I remember.
Yes. That one below B, between B and C4, that's beam 1.
This one.
No, yeah, that one, yes.
Don't you think it's
that
B1,
one.
B2, B3? Then where's B2?
So that should be, the top one should be B1.
Let's check. B1 and B2 same size. So it's
Yes.
the ones that are on top. Yeah. B1 and B2 are the same size. So what I would think is that you can do this one or you can do this one. It's a mirror image of the other. Can you see?
Correct.
Even if you do this one, you show the bolt holes here and here. It's the same person. It's the same as the other person who's going to do this one and show the detail here and there. It's the same because same size and they are connecting to the same columns.
And the base plates, everything will be the same. So if you turn that one upside down, it doesn't matter.
Yes. So you can either do the second one or the one on top. So let's say we are, okay, it's different. Do you know this one is different because of this connection here?
Yes, I see it now.
It's different. So now if they say you can do any of the two, so this one is more work, that one is less work. Why this one is more work? Because obviously you need to determine the position of both holes here.
Correct.
And then position of both holes here on C4 and there on C4. Then on top you come and do the end plates here, fully detailed. and the end plates, they are fully detailed. Otherwise, B3 is straightforward. There's only two connections. It's on the right and on the left. There's no other column in the middle there. But even if it's like that, you can show the column center from here to the end here. This is the column, 625, 625. All right, so now, the first thing that you need to know, I'll try to open AutoCAD for you. This I did, is this column? No, it's the column, this one. Yeah, it's an example. I'm not sure if it's the one I was doing or what. Let's look at this. This one was B1, and yeah, there. This work was one of the students' work. So I'm not sure it was assignment that is on Google Classroom. I think assignment 2. Let's check. Yeah, it should be assignment 2. You must check from last block. Though it's not that clear. So what he's doing here, this guy, this is the layout, and it has already been scaled down. At the end here, though it didn't show the detail of the end plate, it's the mirror image of this one. So he was supposed to say 2 of, you understand, like here, he's saying 4 by 2, but the end plate he has shown one side. What if they cut only one end plate? It's supposed to also have on the other side. This is your end plate here. Okay, once you do the end plate, and the size of the end plate should be in the height. Let's say that you can see it here. Let me highlight it. This is the end plate. You must go up by 10. It shouldn't just flash here. You can go out by 10 to leave for welding, usually 10 fillet weld. So we usually go out by 10. Some of them prefer having it smaller as long as the I-beam is big. You can even have a small end plate here, just here, that size. But the hole positions are very important. I'll start by talking about how you position the bolt holes here. Firstly, do you agree that here there's an I-beam in the center here? Let me just try. Yeah, though it didn't show.
You didn't show it, yes.
Correct. There's supposed to be an I-beam. That's why it's not even nice to flash like that. So let's see which size it's working with. What's the size of this beam? It didn't even show. You must show here. You say there is the size, sorry. You see the size?
Yes.
254 by 146 by 31. So if I'm to bring this beam, let me just try to open it. File. Then you say open. 254 by 146 by 31. And not the templates. I need the symbols. Where did I keep my symbols? This is template. Symbols. SSD. Universal beam. Okay. Okay, that is H section, I section, parallel flange, this one. You open, then change here to drawing. And we are looking for 254 by 146. You see by 31, this one. Double click. That is the I section. That's the one we are looking for. So it opens in a different window. What you do, just Control C or copy to clipboard. You go back into the working window here and then paste. You see how big it is because this one is scaled down already. So you scale down this one to 1 to 10. Scale 1/10. Enter. Okay, so what I was trying to say, let me move from the midpoint here to the midpoint here. It's sitting like that. Okay, that's what we are saying. Can you see?
Yes. Yes. Isn't he supposed to have a sectional view also available for you to see section AA on the side?
No, not necessary. They only want to see on the ends, end plate detailing, not sectioning. Yeah, you know the reason I brought this I-beam here. I know it will be in hidden details if you look from the right-hand side because it's behind the end plate. You understand?
Correct, yes.
Now my point is, how did he get the position, meaning that the distance from this hole here, both hole, to this one here? whatever the distance he got, because it's under the scale now, it's 140, he got 140. Where we get this distance, we call this one a gauge distance. A gauge distance is a distance from here to there, along, or we say across the web. Okay, so this size of the beam, you need to go to the blue book. Let me go to the blue book. I've got it open there. When you go to the blue book, are you able to see the gauge distance, G1?
It's a bit blurry, but I can see it. Yes, I
Let
can
me
see
see.
the.
I think I've got another book open with the things. Let me see. Structural steel. Yeah, this is the book. I think in the book it will be clear. Let's go to the gauge distance table. SSD. Yeah, here. It's the same table that is in the blue book.
Yes.
Okay, so this is recommended gauges. You have to come to this table every time in the exam to get the G1. You see G1 is from center to center. But
Correct.
for you to know that G1, you need to know the breadth. You see B. Our B was 143. Am I right? I think it's 143. The size of that beam. Let me just confirm. Yeah, 146 there. That's the breadth. The height is 254. Height means it's from the top of the flange to the bottom of the flange. It's 254. Then this 146 is the distance from end here to end there. And that is what determines the position of those gauge distances. So this is 146. Can you see?
Yes.
So when we are in that book, we have to check 146. These are the B. 146 is here. Can you see where it lies?
Yes.
Yeah, and they are saying minimum for all I sections and H section. So for 133 to 146, the G1 should be 70. So 70 meaning from the center is what? 35, 35 going away, because 70 is from center to center. But if you use the center of the web, you offset half of 70 and half of 70.
Yes.
Okay, so that's how we get this distance here. So this was what, 140. For whatever reason you used 140, but the recommended should be 70.
70.
Yes.
So you should come in with these.
Correct. Correct. Now, once you know how to get that gauge distance, you need to know how to get the distance from the end of the plate to the center of the wall position. You understand? From the edge, we call it the edge distance.
Yes.
From the edge of your plate to the first hole position, from edge to edge. Also, there is a table. I'm not sure if it's which table in this book for the edge distances. Okay, I'll go to the blue book. It's open there. Just hope you'll see. When I come to the edge distance, recommended edge distance, there's a table. You must check nicely. I know it's not that clear. Table 3.14. It's showing recommended minimum and recommended edge distances and spacing for fasteners or for bolt holes or bolts themselves. This is the end distance. Distance from the end of a plate to the center of the bolt hole. So what size bolt are we using? 20 diameter. There.
Is this very?
Yes.
Just something that's bothered me. Normally when they say, the bolt size is 20, and then if you drill a hole, you normally make it 2 millimeters
22,
bigger.
yeah. It's going to be
Yes.
bigger.
Yeah,
Yes.
okay, right. Just making sure we're on the
Yeah,
right
well, it's
place
going to
here.
be bigger. We always go because to accommodate for threads and all that. Yeah. So it's 20
Right.
drilled hole. Okay. Then if we put the threads, it's going to go to 22 because you have to do tapping, thread making inside. So if you use 20, my point is that you need to come to 40. Can you see minimum is 40 edge distance?
Yes.
Yes, from the edge of the plate to the center of the hole, it's 40 minimum. You can go to 45 or 50, but you can't go less than 40. Clear?
Yeah.
Okay. Then this is recommended pitch. They say the pitch is the distance from the center of the hole to another hole along the length.
Yes, which we now just confirmed.
Correct. Along the length is 70. So when 70 is different from the gauge, let me go to the drawing and see what is a pitch. When we come to the sketch here, The pitch is from this hole to that hole. If there's another hole to that hole, you know, going that way, that will be your pitch. So they are saying recommended minimum is what? 70. So if you use 2 times like 150, 140 is fine. You know what he has done? He was assuming that because this beam is too long, the height is too much. So you can't use here 70 and 70. They'll be too close to the center line and you remain with a lot of material there. Otherwise, what you can do, you can have a hole here at 35 from the center line, another one here. But it means you have to reduce the size of the end plate. You understand? Let me show you. If you
Yeah. I see this is marked at 30. It should be 40.
Yes.
That's
So
on
what
the
I'm
side, maybe
saying,
as well.
what I'm saying is let's try to offset the center line. If I offset the center line by, let's say we want to use how much pitch? 70. Then if I use 35, then I say enter. Then I offset this one. But it won't be 35. It's 35 divided by 10.
You already scaled it down.
Yeah. 3.5. Enter. It's gonna be like that. Okay, then you can also move this and that. It won't be wrong if you do this. I just want to show you that you can also, and then move this. Somewhere there. And then so that you maintain the 70, but it means this one, we have to have 40 minimum here. Offset 4 point, minimum is 40, so 4, enter. From the center here, coming out. It means that that is the point where the end plate should start. 40 or 50, because minimum is 40. You can cut it that way, but it looks very weird. Can you see they are too close to each other?
That does make sense. That's
Doesn't make
definitely in the
sense.
middle,
So you can come,
should go down.
you can ignore the, oh, this is the center line. It's me who messed up. It's
You
me.
should
Yeah.
go- you should
This
go
is
down
the
40.
center line, yeah. So let's say offset 3.5, enter. Which one was the center? This one. Yes,
Correct.
yes. So that's where these two are supposed to sit. Move from the center. Yeah, somewhere there. Then we offset this one by 4, offset 4, enter. That makes sense, yes. Correct. And then you move this end plate. To here. Then you delete this one here. Yeah. Then also here, you offset this one by 4, offset 4, enter. You offset this one up by 4. If we want to maintain the edge distance of 40, you can also, this one also saves, you know, material because you're not going to cut a lot. Can you see? Then check here that it's, what's this we said from here to here? What was that, 70, right? When we checked the gauge one, G1 or 70, meaning offset 3.5, enter, which is offsetting this one here, 3.5, 3.5. Then you move this from that position to here, and then you move those two there. Then we need to offset this one by 40, edge distance on the right and on the left. 40, 50, minimum is 40. So if I say offset by 5, it's not wrong. Offset 50 here, 50 there. Then I can now make it that way. That way. You see, that is how it can be if you want to do that way. Following the proper hole positioning. Then this won't be 1/5. You're going to come, okay, it will be 1/50 size. Then you forgot this one here. It's from here to there, from there to there. 70, can you see? Then you change this size. It's up to here. And then from there to there. This is saving material so much because if we cut the plate all the way to the top, it's wasting. What is it for? Because the examiner only wants how many? 4 bots here. So this is also wrong. You must delete that, and then you have to extend. You do this. You come here on top there. Let me just switch on that. Okay, I'll trim them. Copy, because the center lines are already there. Then you come here and trim. 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 Then you can delete the yellow ones. And remember, it's a mirror image of what we need on the left hand side. This center line needs to come out a bit. The yellow lines must be in hidden lines because those are both holes. They're inside the material. So you have to change this yellow to hidden line. Come here, you say hidden line. You see? That's what the examiner wants. Then immediately you finish with this, you can mirror to the other side. If you don't want to do to this other side, you can just say 2 off. This one I can mirror. You select mirror halfway of the beam. Enter. It's the same things there. If you want, copy this to the left hand side or just come and say 2 by, you say okay, you edit that. Okay, 2 times whatever. We know that they'll cut 2 of them. Why they'll cut 2 of them? It's the same thing I need there. Instead of me drawing the same things over and over, just do like that. And it shouldn't be on top. It needs to be under there, somewhere there. Must put it nicely there. You understand?
Yes. Can you just go back to the blue book for me quickly, please, by the plate size, by the holes? I just want to check something.
Book? Yeah.
Yeah. There, yes.
Oh, here, gauge distance.
Yeah, the gauge distance.
And this is end distance. The gauge distances are here. Let me go. The edge distances are here. These are the G, which is gauge distance. End distance is from end to the beginning.
Okay.
Which one did you want? This one?
I was just looking at the plate, and that plate doesn't make sense for me because it's way too small to carry that type of.
Yeah, it's fine. You know, as long as you have calculated the center of the holes, and the edge distance is correct, like minimum, like I told you, that is what they are recommending. And then according to this size of the board, it won't shear off. It won't shear off. Because if we go to the bigger ones and where there's a lot of force, which we call the shearing forces and all that, then you must go to the bigger size. And when you increase the size of a boat, look at the edge, the pitch and the edge, it's going to increase.
All right.
Because when we are deciding, I know that it's not part of your syllabus, it's in structural steel. When you come and learn structural steel, it's when now you start designing which type of boats I'm using at the end connection. And then, if I choose this type of a boat, why this type of a boat? It goes to the amount of force or shear force that is inside the beam. Not only the shear force, there's a lot of forces acting at the connection. Can be the forces coming to the boat, the forces on the beam itself, all that can cause the boat to shear out. So for you to avoid that, you need to do some calculations. But this is just basing on the standards on the tables.
Okay.
And that's where they calculate the number of boats to use. I think in your syllabus, we don't teach you like how do you calculate the number of boats. Because what we do to calculate the number of boats, you need to know how much is the force coming to the beam. If I get maybe 200 megapascals, then I need to know how much is one boat going to accommodate. What is its strength? Maybe one boat has got a strength of 50 MPa. Then you need to say 50 divide into 200 megapascals. Then you know how many boats you need. You know, it goes to you knowing how much force is coming to the beam and knowing how much one boat can accommodate.
Okay, yes.
Yes, once you know how much the force one boat can take, then divide that amount into the total force coming to the connection. Then you know that, I need 3, I need 4. Of which size? Then you go into determining the size of the boat.
Yes.
Okay. So if we go back to the drawing again quickly, this is what you're supposed to do also to beam number 2. I don't know where I was getting measurements, but at least I've shown you how to get. Beam number 2 is 203 by 133. You need to go and look for that beam, come and put it here, then look for the gauge distance for that beam. I don't think 203 by 133. Let's check on the blue book. What?
But if you look on his drawing as well, you know, the side, from the side of the one bolt to the face of the plate, it's 51 on the side, and the other side is 52.
You see, it's not accurate. And here he's using 30, but they are saying minimum for 20 is 40. You see?
Yeah.
So this is wrong automatically, because that's not what the book says, or that's not the standard. When we go to the blue book with that 203 by what? What's this one? Let me just go back again. His beam is 203 by 133. And then when you come here, 203 by 133, the steel is supposed to use not 30, because he's using M20. M20 minimum is 40. You can go to 45 or 50 edge distance, end distance. It's fine, because you are not less than the minimum. It's okay. But not less than 40. That's what you are supposed to do. Then 70 is minimum. You can go to 80 or 100 or 120 is fine, as long you don't go less than 70 pitch, center to center. That is the goodness. Then when we come to that edge distance of 203, gauge, 203 by 133, yeah. So the width, the breadth is 133. You come and look, 133 is here, can you see? It's still between 120 and 146. So it's 70 also. If it becomes bigger, if the breadth is bigger, then you can see it's also increasing here on the gauge. You go more, 140. 300 and above, that's when we have G2 and G3. Can you see? You include those ones, because the breadth of this flange is now wide. You can't only work with G1. You need G1, G2, G3. That's from 305 and above. This box on your right hand side is only for angle ions. You see, if it's the angle ion, yeah. So we're not dealing with that, we're dealing with that. When I come to the truss detail, truss, that's where you get the angle ions. So we'll be using this table on the truss to get the G1. And then from hole to hole, going along the length, that will be our pitch. We make sure it's always minimum 70, 70, 70. And it's more importantly for you to work with 70. If not 70, you go to 140 unit times 2. It's fine. We assume that in between there will be another board. You can go from 70 to 140 times 2 like that. So you can't get 70, 75 as a pitch. No, because standard is 70. So if there's 70, I can have another one at 70. But if I skip that one, I can include another one at 140. Then I don't show anything in between. You see? Yes. So we'll do that one on the truss. So his one is supposed to be 70 for 133. But when you go back to what he did here for beam 2, look, he has used 140, meaning that he's assuming that there's supposed to be one here and one here. You understand? Then he has increased this size. But why even increasing that size? Already you have also reduced the edge distance here. Unless you increase to this amount, but make sure that here you stick to minimum recommended. Okay, that is how you do. When we come to the pitch, he's using 100 from where, and here he's using 51. He was supposed to just say 50. It's not wrong, because minimum is 40. And then he was supposed to show hidden details here. He just shows a center line. You have to show hidden details on the plate. And again, if you look, you see the beam length is starting here. The beam length doesn't start at the end of the end plate. It starts here, inside to inside. Did he show? Yeah, he has shown the beam length, because the question says show the beam length. Show the column center. He has shown me one column center here. Where is the other column center here? Because this beam 2 was also going to another column here. So you have to show the column center. So this, I don't know what he was measuring there. Coming to here, no, it's wrong. It must come to the column center, like the top one. He has shown nicely the column center, but he has forgotten to put another center line here, because there's a column for him to show the detail here, you see?
Yes.
It means there's a column here, and he has to show the bolt holes position in hidden details, and show a small piece here with a cut flange to show what? The position of the bolt holes. That is how
Yes.
it's supposed to be. So when you are positioning the bolt holes here, which he didn't do, so let me just take an example. If the flange has got a width of this much, do you know that when you go to the top view, you see the flange, and in between here, let me just do that piece. The web is in between, in hidden details. Let's say like that. I'll delete this and delete that. From the top view, this will be in hidden details. Do you know that? Or bottom or top view, whichever you're looking from. Then here, it's supposed to be, let's explode, and then we cut. What the examiner wants is you to show like that, because it's just a piece. You come straight, you come in, you come out, yeah, something like that. Just showing us from the top that it's been cut from. Then trim. Then you're going to offset or mirror this one to the other side. Mirror halfway. Yeah, but this one should be going to the outside, something like. You just show a cut, and then once you cut, you can show the position of the holes here. How do you show those positions? You go to the tables again. On the tables, you need to know what is the edge distance. Remember, the G1 from the midpoint here. I'm just now working fast. If this is my center line, it means that I need to offset 35, 35. Okay, to show the position of the holes here. In that case, whichever way 35 is going to be, maybe it's here. You're going to show this hole, then copy 70 down to that side, whichever, 70, and then you copy pitch. You can work with a pitch of 70 or 140. If we work with 140, then examiner wants you to show the center line from here. Let me just switch off that. Copy. This will be another one here. This is the center line. After that, you say copy this same one to the end, to the end, to the end, to the end. Remember, this should be 22 when you're drawing these holes here. It's 22. Then once you do that, you're going to trim and trim. This will be a center line. That's how you show the things on the beam. Center line. Change that to center line. Then match the properties to this one. Change those two to hidden details. Yeah. Then this can be green. It's a cut. Just make sure that you cut. I'll show you. This one shouldn't be going inside. Outline. Because it's a cut, it must be on the other side. Okay. It's a zigzag. Make sure you make it like zigzag.
Yes.
You know those cuts, yeah. And then once that is done, examiner only wanna see that. You can delete this and delete that. Then the centers you don't need to delete. We need the centers on these holes here. Also here. So the secret is, what am I seeing and how do I get the dimensions? I know it's offset. Then I can move this one here and this one here. Yeah, to there. You need to have center lines, match property, this one to there. Then copy this one here, this one here, this one here. Yeah. Then match property for the holes, they must be also green, or construction line. You can use construction lines or green. Green is too thick for structural steel. So when you come to write exam, you find that others are using this as construction. You can work with construction, like red. Every green you change to red, because it's a bit lighter. Even when you print, it's not very, very dark. But it's either way, you can use outline as well. And then once you finish, you show the dimensions. So I want this one to be a center line, but this we don't need. You can just delete. This is the hidden detail for the flange, because we're looking from underneath. This is a flange, this is a web. So the hidden detail for the web is underneath. And that is where we measured from to get our G. This from center to center is the G1. From center to center is the G1. Okay. And mostly because you are going to have a column that is going to be connected here. You must work with a G1 for the column. In many cases, when you're having a column joining to a beam, because you might have the hose bigger, and when you bring a column here, you find the column is not what? Is not fitting. So when you come to getting the distance from here to here, you come here, if it's back to the drawing. Let's say we are doing this B1. When you are doing B1 here at that point, do you agree that this column will come with the end plate here? Not end plate, cap plate.
Yes.
It comes with a cap plate, but how did they position the hose on the cap plate? They used the size of what? Column.
C2.
Yes, C2. So even you, when you're doing the hole position here for the beam 1, don't use the one for beam 1, use C2. Because what
Yes.
determines the hole position on beam 1 is C2 position. Clear?
Yeah. These examination or exam papers, do you have them on Google Drive?
Yes, they are there. I've posted from last year, or 2020. They are there.
Okay.
And then when we are
And-
positioning the bolt holes on the column flange here, what determines the bolt holes on the column flange is B1, because the beam 1 comes with the end plate already welded with it with already holes drilled. So as you are bringing your beam with the end plate, you need to align the holes on the beam to the holes where you're going to drill on the column. But when I want the holes here at the beam here, I need to know the hole position of what? C2. So if this C2 was, check the size here, 203 by 203. You were supposed to go to the blue book, 203 by 203, and then we come here. 203 is here. It's 1/4. 1/4. And what does it mean 1/40? From the center of the web, it's 1/40, 70 to the right, 70 to the left. Then meaning from holes to the next hole there is 1/4. But if you measure from the center, it's 70 to the left, 70 to the right. Why am I using 203 for the universal beam? Because that is the one that will determine the hole positions on the beam flange. And when we come to AutoCAD here, what you need to know is from here to here, you use the column detail to get that information for the gauge distance. But when we come to this side view from here to here, we use the beam detail because it's the beam that comes with the end plate. Here, it's not the beam that comes with the end plate here, it's the column. So that will also tell us which position are the bolts going to be drilled. It's according to the cap plate on the column.
Yes.
All right. Any questions?
No. I'll go through the question papers and answers and see how they worked it out as well, just to make sure about everything.
Yeah, go through the question papers, and the other thing, there's also a PowerPoint slide that I posted on Google Classroom. It's this one. It's for SSD. You see?
Okay, when did you post it last year?
Last year also. So you can just go under structural steel and scroll. If not, you just go to stream, main contents. You'll find it down there. It's got everything, whatever you're looking for, more information, because we made it easier for students at least to summarize the things. Even when you come to that table, you'll find it here. And then also read on the welding symbols, because in theory, they can ask you about the welding symbols, these symbols here.
Okay.
So we'll see you next time. I don't know in the other subjects I'm going to meet you. This subject, if there's a subject they pass like with 100% is structural steel. Here in the African Academy, students are passing 99, 98, you know, it's 100% pass rate every time because it's just understanding your views, you see.
Yes, yes.
There's nothing to think. We have already drawn the structures for you. Like you saw the way I brought the I-beam. I brought the I-beam first because it's already there for you. You can't draw, just copy and paste.
Correct. Yeah, just know your route to the server, how to find it on
Yeah,
the
from
server.
the server, yes, under public. Yeah. All right. If there's no questions, we'll see you next time then.
All right, okay. Thank you.
Okay, it's my pleasure.
Bye.
Bye.